Hey, here we go. We are going to move on into Module 7. And so get out your notes packet for 7-1. And here we go. On your essential question, here's what I want you to write down. It matches what we have in the book. Basically, though, I usually change the words to be I rather than you. So write this as your essential question. How do I write and solve one-step inequalities? And again, if you need a little bit of time, pause the video so you can catch up and we'll go from there. Okay, now we need to talk about what on earth an inequality is. And so what it is it's a math sentence. Just like we did all of Module 6 with equations, we're going to have another math sentence, this and this, separated by an inequality symbol, which basically says that these two values are not the same. They're not equal to each other or not equivalent. That's what we have right there, not equivalent, okay? All right, so and I'm actually going to make sure I've got my ink on right here. Stick with blue, okay? All right, now you have a bunch of symbols that you should see. And if you need to put the words on there to make it more concrete, and so you remember, this first one is less than, next one greater than. And so basically think of it this way. We're reading from left to right. And so as we look at these, you just kind of think the pointy end points to the small one. This is S less than or equal to. This one is greater than or equal to. And finally, we don't use this one as often or as much, but it means not equal to. Okay? All right, so let's see what we've got. When we're thinking less than, I want you to think about these phrases. Smaller than, fewer than, it's below, it's a quantity that's not as big as, or any of those phrases. Those are things I want you to key in that might be telling you to use this symbol. Likewise, for greater than, you can think of these phrases: bigger than, more than, above, exceeding. Those all represent that. Now, it gets a little tricky with these ones when you have the equal sign in there as well. So let's talk about this a little bit. The next one is less than or equal to. And so if you hear phrases like at most, or no more than, a maximum of, or not greater than, those are good phrases to think of that inequality symbol. The next one, greater than or equal to, at least, no less than, a minimum of, no smaller than. And finally, the last one with a not equal to, just not equal. There you go. All right. Cool. So as we start to look at all of these, then let's see what we can come up with for getting your, I'm trying to boost this up a little bit. There. Here we go. So the addition property of equality. All right. So as we're looking at this, let me try to extend this page a little bit so we can bump this up for you. Okay. All right. So write down this inequality statement with me here. If I say something like 3 is less than 8. Okay, I know that's a true statement. If I added to this some like, let's add 5 and add 5 to the right-hand side as well. I'm going to put a bar there, much like we do when we solved equations. And I get another statement, looks a little different. 8, 13. Is less than still the operator that makes sense here? Is this still true? Well, of course it is. Cool. So you could test this out with a variety of other types of numbers, whether it's a fraction, a decimal, a positive, a negative. And basically what you will find out is that no matter what happens, that you can add, I'm going to write this big, and so I'll probably trickle into outside the box here. You can add the same number to each side. The same number. If I abbreviate that with the hashtag, keep in mind that's the symbol that meant number a long time ago. You can add the same number to each side. And the inequality stays true. Sorry, my Y there looks kind of blobby. Stays true. Cool. Same thing with subtraction. Let's look what happens. What if I take 3 is less than, no, let's pick something different. Maybe like 7 is greater than 4. And I said, all right, what if we subtracted 5 from each side? Subtract 5, subtract 5. I'm subtracting the same value from each side of this inequality. I get 2 and -1. Is 2 bigger than -1? Sure it is. So, likewise, you can subtract the same value from each side of an inequality. You can subtract the same number, sorry, I'm at home. I'm using this stylus and it's a little wonky. The same number to each side. The inequality is true. Bump this up a little bit. Now that opens up all kinds of legal moves now when we try to solve an inequality. So let's take a look at a few examples that you have. Here's the first one in your notes. X plus 5 is less than -12. Now, just like when we had equations, your goal is to isolate the variable. Draw a line under this symbol, okay? All right, get X by itself. In order to counteract that plus 5, subtract 5. Do the same thing over here. You get -17, and I know because of the property that it's going to remain less than. X is less than -17. That is my significant number for this inequality. So find -17 on the actual line. And by the way, your notes may not actually have values in here, so why don't you fill these in? -17. It's less than. I want numbers smaller than, so I want all of these numbers down here. Everything works. Everything works until I get way close to that one. The way we indicate this is you're going to make the arrow that points to the left for less than. Fill it in, make it large. Leave this circle open though, because -17 itself is not a solution. Is -17 less than -17? No, that makes no sense. So we leave an open circle there to indicate that. Let's look at a few more. Here's one. 8 is less than or equal to y minus 3. Your goal is to get the variable isolated. So add 3 when I do that, sorry, this got way too big. Come on, come on, come on. Whatever. Good gravy. Technology. All right, so on this one, this adding 3 wipes out or counteracts the -3. You have a y left over here. My property says the inequality symbol stays the same. And you're left with this. 11 is less than or equal to y. Oh my gosh, don't leave it this way. I like the variable on the left and the number on the right. The pointy end is pointing at 11. So we need to make this sign look like this with the or equals to. Y is greater than or equal to 11. Here's how we write this. All of the numbers bigger than 11, all of this stuff here, or exactly equal to 11. This time, 11 is a solution. So we still put the circle at 11, but color it in solid. Shade to the right because we want everything larger. Color in the arrowhead. There you go. And the reason we do this and we graph it each time, there are so many solutions. You could never possibly list them all. Okay, that's why we do that. All right, this next one. Your goal, isolate the variable. So you need to add 5 to each side of the inequality. Yay, hooray, that goes away. Y greater than or equal to -2. There you go. Find -2. Put an open circle there. Now we're talking greater than. I want all numbers bigger. And if you start to notice, the variable, if it's on the left, will give you then the symbol. That's the direction you're going to shade. We're going to fill in the arrow for greater than. This time, however, though, it said it could be exactly equal to -2. So -2 would be a solution. Is -2 greater than or equal to -2? Well, they're not bigger than each other, but they are equal, and that's enough to make this a solution. Color in -2. Okie dokie. Let's take a look at this bottom one. My variables on this side, I'm adding 12. I've got to get rid of it. So let's subtract 12 from each side. Now watch what happens. There we go. Make this a little neater. Okay. When you subtract 12 from each side, yay, hooray, that goes away. I end up with 9 greater than x. I just don't like them written that way. I like to put the variable on the left, the number on the right. Pointy end is facing toward x. It's almost like a flip it. X is less than 9. Put a circle at 9. Less than means go to the left. Fill in this arrowhead to indicate that you are going on for eternity. We kind of darken up this line to indicate all of these numbers, but I'm going to leave that circle open. That indicates that number 9 is not a solution. 9 is not less than 9. That makes no sense. Okay. All right. Next, we want to start talking about multiplying and dividing. What I'm going to do for today is I actually want you to stop here. We're going to pick up here on Monday with multiplying and dividing because there's a little something tricky coming. So what I want you to do is check Schoology. You have your packet. This assignment will be in your packet. Check Schoology for the exact problems. Alrighty? Good luck, and may the force be with you.